Hello dear students. So in this video we will be discussing kinematics PYQ from April 2024 attempt. Before this we have also discussed January attempt PYQs. You can check the link in the description box. If you find our videos helpful, do consider to press the like button and subscribe to our channel. Let us start with this video. Yes. So the first question that we have, it is your 4th April shift 1 question. It says, a body travels 102.5 meter in nth second and 115 meter in n plus 2th second. Find the acceleration. Okay. So what do we know? The displacement in nth second. What is the relation for displacement in nth second? Sn is equals to u plus a by 2 2n minus 1. We'll use this relation. For nth second, the displacement is given to you 102.5, which is equals to u plus a by 2 2n minus 1. For n plus 2 second, it is given to us 115. 115 is equals to u plus a by 2. Acceleration will be same only for the same journey. For constant acceleration will be same only. So u plus a by 2 2 times n plus 2, because we are talking about n plus 2th second minus 1, right? You can solve this further. 115 is equals to u plus a by 2. When we'll solve this, we will get over here 2n plus 3. Equation number 1, equation number 2, right? Let's simplify this. We want to find out acceleration, so we'll do 2 minus 1. If we do 2 minus 1, 115 minus 102.5, that will be 12.5. I am writing it as 25 by 2, right? 25 by 2. This is equals to u minus u cancels out. Over here it will be a by 2, 2n plus 3 minus a by 2, 2n minus 1. I am taking a by 2 common over here. We will be having 2n plus 3 minus of 2n minus 1. So 2 cancels out. 25 is equals to a 2n plus 3 minus 2n minus minus plus 1. 2n cancels out. We have 3 plus 1 4. Ultimately acceleration comes out to be 25 by 4, which is your 6.25 meter per second square, right? You can check the option is there in front of you. Let us move to the next question. Yeah, so we have our next question. A cyclist starts from point P of a circular ground of radius 2 km. The radius of this is 2 km. It starts from point P and travels along its circumference to point S. That means from P it reaches over here. The displacement of the cyclist, is. How to do this? It's a simple question. Displacement is what? Basically the shortest distance between initial and final point. This is your initial point, this is your final point. Let us join them. If we look at it, this radius, this is 2 km, this is also 2 km. So this PS distance by Pythagoras directly we can say it will be your 2 root 2 km, right? And 2 root 2 as we know can be written as root 8. Basically 2 root 2 is root 8 kilometers. So our answer will be root 8. Yes. Third question, let us see. It says a bus moving along a straight highway with speed of 72 km per hour is brought to halt within 4 seconds. Fine, let us see. So u value is given to us 72 km per hour. 72 km per hour, let us change to meter per second into 5 by 18. When you will do it, it will come out to be 20 meter per second. Okay, it is brought to halt within 4 seconds. That means final speed becomes 0 in time 4 seconds. Well and good. After applying the brakes, the distance traveled by the bus during this time is fine. So basically it's a straight line motion. The displacement and it is going in one direction only. So your distance and displacement will be same only. Straight line motion going in one specific direction, distance displacement will be same. Fine. We want to find out the distance So what can we do? First of all, let us calculate acceleration. We'll use first equation, v equals to u plus at. 0 is equals to 20 plus a into 4. Acceleration, we get it minus 5 meter per second square. This is the retardation of the bus. Now we will use this in our third equation of motion. What is that? V square equals to u square plus 2as. Finally, the speed is 0. Initial speed was 20. It will be 400 plus 2 into a. How much is our acceleration? Minus 5 into s. So we calculate it. Let's bring it this side. It becomes your 10s is equals to 400. S is equals to 40 meter. Displacement is coming 40 meter. Because it's a straight line motion in a same direction, your distance will also be 40 meter only. Yes, let's see the question we have. It says a body moves on a frictionless plane starting from rest. U is equals to 0. U is equals to 0. If Sn is the distance moved between t minus 1 to t equals to n, yes, we understand Sn second displacement is and the nth second, n minus 1 to n, fine. And s minus 1 is distance moved between n minus 2 to n minus 1. These are basic definitions, fine. Then the ratio of s minus 1 by Sn, that is this s minus 1 by Sn is given to us 1 minus 2 by x for n equals to 10. Well and good. Find the value of x. Let us do. Again, this is the second question on our nth second displacement. Let us use the relation. So Sn is equals to u plus a by 2, 2n minus 1. Okay. U is 0 for 10 second. Sn is basically for n equals to 10. That means for 10 second, first of all, let us write down. It will be a by 2, 2 into 10 to 20, 20 minus 1 is 19. So we are getting over here S10 is equals to 19a by 2, equation number 1. Fine. Now n minus 1 will be 9 seconds. So what is the displacement for 9th second? S 9th will be, u is anyway 0. So a by 2, 2n, that is your 18, 18 minus 1, 17. So we are getting S9 is equals to 17a by 2, equation number 2. Fine. Let us take the ratio S9 by S10. When we take the ratio, we get over here 17 by 19. I hope it's okay. 17a by 2, 19a by 2. We will get 17 by 19. This is given to us in the question as 1 minus 2x. Solve it over here. So what can I write it? 2 by x is equals to 1 minus 17 by 19. This, if we solve it, I'll do over here. So 2 by x is equals to 2 by 19. 2 cancels out. X value comes out to be 19. Right. So answer for this question is x is equals to 19. I hope the procedure and the calculation is clear to you. Let's move ahead. Yeah. The question says a train starting from rest first accelerates uniformly up to a speed of 80 km per hour. Okay, let us draw a situation. So the train is starting from rest, u is equals to 0, acceleration is constant, and the speed becomes your 80 km per hour. And all this happens in a time of t. All this thing happens for time t. Okay, then it moves with a constant speed for time 3t. Constant speed, that implies once it has got 80 km per hour. So for next 3t time, it will move with a constant speed of 80 only. Well and good. They are asking us the average speed of the distance of the train ठीक है, the average speed of the train for this duration of journey will be in kilometer per hour. Okay, they've given us in kilometer per hour, so no need to change to meter per second. Let's solve it for this part of the journey. And for this part of the journey, two parts. One is your accelerated motion, one is your constant. Acceleration is 0, this is constant velocity motion, right? Uniform motion, non-uniform, and non-uniform also, this is your accelerated motion. Fine. What is our speed average? Speed average is total distance divided by total time. Total time we know in variable terms only, but we know t plus 3t, it is 4t. Let us calculate distances in terms of t. We will get our average speed. So in this part of the journey, this is accelerated motion. What can we write? Distance, or because straight line motion, so s equals to ut plus half a into t square. U is 0, right? Over here we don't know acceleration. Can we calculate? Yes, using first equation we will calculate our acceleration. So v is equals to u plus at. V is 80. 80 is equals to 0 plus a into t. So a value comes out to be 80 by t. I'll substitute this acceleration in our first equation that we have got it. So this is our distance, or the this part s1, and this is your s2. So s1, what can I write it? 1 by 2 into 80 by t into t square. Cancels out, we are getting ultimately 40t. We will require this. The first distance, in the first part, the distance is coming out to be 40t. For the second part is simple story. It is going with constant speed, so we can write down distance traveled in second will be equals to speed into time, which is 80 into time is 3t. 8 3 24, 240t. This is our second distance. So now let us put this into our average speed relation. Speed average will be equals to total distance 240 plus 40, that will be your 280t divided by total time. Total time is t plus 3t, which is your 4t. T cancels out, we get over here 70 kilometer per hour, right? So your speed average is 70 kilometer per hour. Let's move to the next question. Yes, so let us see. What equation we have is a body projected vertically upward. I have drawn the figure for you people. See over here. A body projected vertically upward with certain speed from the top of a tower reaches the ground in time t1. So the situation is that a tower, let's consider its height is h. It's not given to us. We have taken height as h over here. So, and from the top it is thrown up with a speed of u. It goes up and then comes down. It takes a time of t1. Next, if it is projected vertically downwards from the same point with the same speed, it is happening from here only. Just for clarity of the diagram, I have drawn the situation over here. That the particle is thrown from the same height with same speed but in downward direction. That means u is in downward direction and it takes a time of t2. Next it says if it reaches the ground in t2, fine. Time required to reach the ground if it is dropped from top of the tower. Dropped means released. From the same height, if it is released, how much time it will take? Let us assume that time taken is t. So t time we have to find in terms of t1 and t2. All the options if you check, root t1 t2, root over t1 minus t2, root t1 by t2, root t1 plus t2. So this t we have to find out in terms of t1 and t2. Let us see how to proceed with this. So it's a basically question of your equation of motion, and to be specific, your motion under gravity, motion in y direction. How to deal with it? Situation number 1. Situation 1, in that motion under gravity, if we see how much is the displacement, what is the total displacement? Total displacement over here is this, the height of the building, and it is in downward direction. I am taking downward direction as negative, upward direction as positive. So if we use second equation of motion for the situation 1, what can I write it? Minus h, because it is displacement is downward, is equals to u t1 minus half g t1 square. Equation number 1. And g is downward, negative. For situation 2, again the displacement is equals to height of the building only and it is downward, so minus h. minus h is equals to thrown downward. Speed is in downward direction. That means velocity direction will be negative. So minus u t2 minus half g t2 square. Equation number 2. If we write down for the third situation, the one which we have to calculate time for, right? So this one I can directly write minus h is equals to minus half g t square. Equation number 3, we have to calculate this t only. Over here, this will be your h is equals to half gt square. That means basically somehow that we have to calculate this h in terms of t1 and t2, in terms of t1 and t2. Let us solve. Your physics is still here only. From now onwards, means from this point onwards, it is all your maths. And there are different ways of approaching of these equations. Let us take one of them. So what I will do is, I'll do, let's say 2 minus 1. This equation 2 minus 1, if I do this side, it will become 0. This is equals to 2 minus 1. When I do it, it will become, or let's take 1 minus 2, that will be better. 1 minus 2, if I do it, this side anyways, LHS side, it is 0. This will be your u of t1 plus t2 plus half g t2 square minus t1 square. Please take a look. 1 minus 2 I have done over here, right? From here, let us calculate this u value. What can I further write it? This over here will become minus g t2 square minus t1 square is equals to u times t1 plus t2. Fine, well and good. What do we have it? This is t2 square minus t1 square, a square minus b square. If we write it, if we apply over here, we will get it t2 minus t1, t2 plus t1. This is equals to u times t1 plus t2. t1 plus t2, t1 plus t2 cancels out. We have u is equals to, this minus goes inside, so we have 1 by 2 g t1 minus t2. This is your initial speed, we have got it in terms of t1 and t2. Let's put this u in any one of the equation. I am using it in equation number 1. So let us see, in equation 1 I am using u. Minus h is equals to u, if I put it, half g t1 minus t2 into t1 minus half g t1 square. Let's simplify this. Minus h is equals to minus g t1 square minus half g t1 into t2 minus of half g t1 square. I hope till here it's okay. What do we get it? Half g t1 square, half g t1 square cancels out. H value comes out to be 1 by 2 g t1 t2. This is what is your h value coming. That is what we needed. We wanted h value in terms of t1 and t2. So I'll put this into our third equation. So what can I write it? 1 by 2 g t1 t2 is equals to 1 by 2 g t square. Half g cancels out. That means t value is root over t1 t2. Answer, right? This is our answer. I hope the procedure is okay, right? Let's move to the next question. Yes. So the question that we have, it says a particle moves in a straight line so that its displacement x at any time t is given by x square is equals to 1 plus t square. This is x as a function of t given to us. Okay. Its acceleration at any time t is x power minus n. Acceleration is x power minus n. Find the value of n, where n equals to, find. That means we have to calculate first of all acceleration and then check it the value of n. Let's see. This is given to us. Let's simplify this. X square is 1 plus t square. So we can write x is equals to, if I take root on both sides, 1 root over 1 plus t square. First of all, we will find out velocity by differentiating x. Then we will calculate acceleration by differentiating velocity. We will get our acceleration, right? Let's see. So over here, v will be dx by dt. If we differentiate this, how much we will be getting? 1 by 2 times root over 1 plus t square and differentiation of 1 plus t square, it will be basically using chain rule. 1 plus t square differentiation will be 2t. 2 cancels out. So v value comes out to be t by root over 1 plus t square. Fine, well and good. Let's calculate acceleration. Acceleration is dv by dt, right? We will use quotient rule over here. So in denominator, we will get 1 plus t square, and over here differentiation of t will be basically 1. We'll keep this one as it is, root over 1 plus t square, minus of t will keep constant, and differentiation of this root over 1 plus t square, this will come out to be 1 by 2 root over 1 plus t square into 2t. Please see carefully this step. So this is what we have got it. Let us simplify this. Over here, this 2 root over 1 plus t square, if we simplify it, it will get 2 times 1 plus t square minus 2t square divided by this 2 times root over 1 plus t square will come in denominator. It will become 2 times 1 plus t square whole power 3 by 2. 1 plus t square into root over 1 plus t square, 1 plus t square whole power 3 by 2. Fine. So a value comes out. Finally, when we simplify, this is 2 plus 2t square minus 2t square. 2t square cancels out. We only have 2 by 2 times 1 plus t square whole power 3 by 2. So a comes out to be 1 by 1 plus t square whole power 3 by 2. 1 plus t square. What is your 1 plus t square? 1 plus t square in the question initially is given as x square. I will substitute over here. So a is equals to 1 by x square whole power 3 by 2, which basically is a is equals to x power minus 3. A is equals to x power minus 3. What is given to us in question? If we compare it, n value comes out to be 3. Right? Let's move ahead. Yes. So the question we have is, a clock has 75 centimeter, 60 centimeter long, second hand and minute hand respectively. Fine. Let us draw the situation. A clock, second hand is given to us 75 centimeter and the minute hand is given to us 60 centimeter. Fine. In 30 minutes duration, the tip of the second hand will travel x distance more than the tip of minute hand. The value of x in meter is nearly, take pi as 3.14. Fine. See over here, they are talking about the distance traveled by the tip. Let's call this as S and this as M. Distance traveled by the tip of the second hand, distance traveled by the tip of the minute hand, the difference between them in 30 minutes. Fine. So let's first focus on the tip of second hand. What do we know about it? In 1 minute, this second hand will make one complete round. In 1 minute, it will make one complete round. That means in 30 minutes, how many rounds it will make? In 30 minutes, it will make 30 rounds. So what is the distance traveled by your second hand tip? Distance traveled in 1 round, it will be 2 pi r. We are talking about the distance traveled by the tip. So in 1 round, 2 pi r. In 30 rounds, it will be 30 into 2 pi r. R for what? R for this second hand, right? So this will be your, I am writing it as rs. This comes out to be 60 pi rs, equation number 1. Fine, well and good. Next, let's talk about your tip of minute hand. If you focus on tip of minute hand, in 30 minutes it will come over here. This minute hand will be reaching at this position. Because in 1 hour it will complete 1 round. So in half an hour, that is 30 minutes, it will go at the opposite end. So over here, how much distance it has traveled? The distance it has traveled is 2 pi r by 2, that is your pi r. So distance traveled by minute hand tip is equals to pi into r of the minute hand, which is your equation number 2. The difference between them they have given as x. Let's solve it. So x is equals to 60 pi rs minus pi rm. Over here 60 pi rs is given to us 75 centimeter, converting to meter, 75 by 100 minus pi into 60 by 100. From here you can see clearly that 60 pi by 100 can be taken common. 60 pi by 100 can be taken common. This will be 75 minus 1, which is your 74. 3 times, 5 times, we have 3 into 3.14 into 74 divided by 5, right? This is what we are getting. When you will calculate it, beta, this answer will come out to be 139.4. Okay, this calculation, when we'll do it, it will come out to be 139.4. This is our answer for X. Let's move ahead. So the question we have, a particle moving in a straight line covers half the distance with speed 6 meter per second. Fine. So half the distance, let's say that this total distance is 2x. So half distance will be x. It covers it in 6 meter per second. Well and good. Let's say that it takes a time of t1. Okay. The other half is covered in 2 equal time intervals with speed 9 meter per second and 15 meter per second. So let's say that the other half is covering it in your half of time. That means over here the other half total is covered in t2. So half of this, that is t2 by 2, is moved with a speed of 9 meter per second, and other t2 by 2, that is other half, is moved with a speed of 15 meter per second. This is what the whole information is given. They are asking the average speed of the particle during the motion. Average speed, how to do it? Let us see. Speed average we know is total distance divided by total time. Do we know total distance? Yes, we have assumed your x and a 2x as the total distance. We'll keep now total time. Let's calculate this t1 and t2 in terms of x, so that we will get our speed average. So over here, what can I write for the first part of the journey? Distance is equals to speed into time. That means x is equals to 6 into t1. So t1 value comes out to be x by 6. Hold it. And now second, for the second part of the journey, what can I write it? X is equals to this part over here. X is equals to over here. This will be 9 into t2 by 2, right? Plus 15 into t2 by 2. I hope this is okay. T2 by 2 taken common. So 2x is equals to 9 plus 15, right, which is your 24 t2. From here we get x is equals to 12 t2. So t2 value comes out to be x by 12. I hope this is okay. Now let us substitute. So speed average, total distance 2x. I'll do it here. Speed average, total distance 2x divided by t1 plus t2. T1 plus t2, if we do, x by 16, x by 6 plus x by 12. 2 times 2x into 12 divided by 3x. x6 cancels out. 4 times 8 meter per second. 8 meter per second is the average speed coming. Yeah. So the question we have is, it says two cars are traveling towards each other at a speed of 20 meter per second. Fine. Let's see. So we have two cars 20 meter per second traveling towards each other. That means we can say this is what the situation is. Fine. When the cars are 300 meter apart, 300 meter apart, okay, both the drivers apply brake and the cars retard at the rate of 2 meter per second square. For each one of them, the retardation is 2 meter per second square and 2 meter per second square. Both are moving with same speed. Yes, fine. Okay. The distance between them when they come to rest is simple story. Let's see. because the initial parameters are same only, initial velocity is same and retardation is also same. So let us see how much distance they travel by the time both of them come to rest. So what can I write it? V square equals to U square plus 2AS. Finally speed becomes 0. U square is 20 square is 400 plus 2 into retardation minus 2 into S. So what do we get it? S is equals to 400 by 4, which comes out to be 100, right? This comes out to be 100. Now see carefully over here. This will be traveling a 100-meter distance, right? This will travel a 100-meter distance. This car will travel a 100-meter distance. Why I am using only one equation? Why I have calculated with only one equation? Because the initial parameters are same. Well, magnitude of velocity is same and the retardation magnitude is same. So both of them will travel 100 meter and come to rest. So from 300 meter, this is covering 100, this is covering 100. So 200 is covered. How much distance is left over? 100 meter. Answer will be your 100 meter. Let's move ahead. Yes. So the question that we have is, the coordinate of a particle moving in xy plane are given by x is equals to 2 plus 4t and y is equals to 3t plus 8t square. Okay. X and y coordinate as a function of time t is given, and they are asking what is the type of motion. Is it a uniform motion, non-uniform motion? Is it an accelerated motion, non-accelerated motion? And what is the path? Let's see. To find out whether it is uniform, non-uniform, accelerated, we will check the acceleration for it. Let's see. So how do we calculate? This is x given to us. Let's calculate velocity in x. Velocity in x will be dx by dt. This is equals to 0 plus 4. So, okay, initial velocity is there in x direction. Acceleration in x will be dvx by dt. This will come out to be 0. There is no acceleration in your x direction, right? Let's see next in y direction. In y direction over here, dy by dt. dy by dt, this will give us your velocity in y direction. Velocity in y direction, dy by dt, this is equals to 3 plus a to 16t, right? This is coming your velocity in y direction. If we calculate acceleration in y direction, it will be your dvy by dt, which comes out to be 16 meter per second square. This is the situation. Let's focus on acceleration part first. You have only acceleration in y direction. There is no acceleration in x direction, and this acceleration is constant. And this acceleration is constant. So one thing is clear, that it's not a uniform motion. No, it's a accelerated motion. Well and good. Now let us focus on the path of it. If you see, 4 options are given. The non-uniformly accelerated, no. It is uniformly accelerated. Acceleration is constant. Okay. Second is uniformly accelerated, having motion along a straight line. Third is uniform motion. It's not a uniform motion because velocity will change. As velocity in x is constant, in x direction it's uniform, but in y direction it is non-uniform. So net motion will be your, net resultant will be your non-uniform. So option 1 is gone, option 3 is gone. Option 4, uniform accelerated, moving along a parabolic path. We have to choose between second and fourth option, whether it is a straight line motion or it is a parabolic. How to decide? One method is you find a relation between x and y. That means you find out trajectory equation and eliminate t over here and get a relation between x and y. Whatever equation comes, if it comes a linear equation, it's a straight line path. If it comes a quadratic equation, it's a parabolic path. Another is directly also you can see it. This is a acceleration, initial velocity. If you see initial velocity you have in x direction, Vx is equals to 4 meter per second, and in y direction if you put t equals to 0, over here also this, let me write it as ux, and in this direction uy is also equals to how much? 3. If you notice, acceleration is in y direction, you have velocity, initial velocity in x direction also. That implies this particle cannot move in a straight line path, right? Because there is some initial velocity in this direction. It will take a path something like this. Now, this will be the path that it will be taking, right? It's a parabolic path. By the initial parameters I decided, another method I told you that find the relation between x and y, you will get a quadratic obviously. With that also we can say it. So our option will be, option number 4th will be correct answer. 4th only, no? Fourth. For you people it's there. 4th option, parabolic path. Let's move to the next question. Yes. So the next question we have, it's your projectile motion question. The maximum height reached by a projectile is 64 meter. Okay. If the initial velocity is half, the new maximum height of the projectile will be. That means, let's say u2 if I call it, becomes your u by 2. So what is the maximum height? Let us calculate. Initially, what do we know maximum height in case of projectile? U square sine square theta by 2g. If this u is made half, then so h dash, let's call it h dash, is equals to u square by 4 into sine square theta by 2g. This whole thing, u square sine square theta by 2g is 64. So h dash value comes out to be 64 by 4, which will be basically 16 meter. So the new height will be your 16 meter. 16 meter will be our answer. Let's move ahead. Yeah. So the question we have, the angle of projection of a projectile to have same horizontal range and maximum height. Range is equals to height. Relation for range is u square sine 2 theta by g is equals to height u square sine square theta by 2g, right? G cancels out, u square cancels. Sine 2 theta we can write as 2 sine theta cos theta is equals to sine square theta. Sine theta again cancel. When we will solve it, we will get tan theta is equals to 4, theta is equals to tan inverse of 4. Theta equals to tan inverse of 4. Check your option. Option number 2 will be the correct answer. Yes. Let's see, the diagram is in front of you. The question says a body of mass m thrown horizontally with velocity v from the top of a tower of height h. So initial situation is, this is height h and it is thrown with a speed of v. Well and good. Touches the ground at a distance of 100 meter from the foot of tower. That means the range in first case is 100 meter. Next, a body of mass 2m, thrown at a velocity v by 2 from top of a tower of height 4h. Okay, will touch the ground at a distance of. Well and good. Let's see. Don't go after the dimension. The parameters I have written h and 4h. Now, range in this case, range is u root over 2h by g. Relation I am using directly. The range for a projectile thrown from the height. R is equals to, which is 100. 100 is equals to v into root over 2h by g. We have got our equation 1. We have to calculate r in this case. Let's substitute. Range does not depend on mass. The masses are given different. Range does not depend on mass. It depends on the initial velocity, horizontal, and the height. So in this case, I can write down r is equals to v. V is v by 2 into root over 2h. Height over here is how much? Height is given to us 4h. So 4h by g. So this 4 when taken out of the root, it becomes 2, and this 2 and 2 will cancel out. We will get again v root over 2h by g. Same story as what we got in last. Therefore, we can say that in this case also range will come out to be 100 meter only. So answer for this question will be 100 meter, right? I hope you found the video helpful. You can check our other PYQ videos also, right? Thank you for watching. Bye bye.